What we will do? So in multicast, we will be traversing or traveling the packets from one to many, right? Yes or no? So if you see in this diagram, it is showing the representation of unicast routing. So here you can see the source and the destination, where the source is sending to the destination D1 by using a route, right? Yes or no? So it is like the way of communication from one to one. So here the communication is between source and the destination. Here the router is acting as a forwarding router, right? So whenever the source receives a packet, so here the router will forward the packet to the destination, right? So here if you see, a packet starts from source 1 and it passes through the routers to reach the destination D1, right? Yes or no? So when a router receives a packet, it will definitely forward that packet only through one of its interface, right? So if you see here the first router, you can see there are two different interfaces where it can travel, right? So if you see here, this is one way it can travel, right? So if it travels through this routers, there is no destination path, right? So it has selected a path. It may go through this way, or it may go through this way, right? Yes or no, to reach the destination. But according to the routing table, the router will route the packets in the from source to destination, right? Yes or no? So here what you will see in unicasting, we will be using only one to one interface, right? Only one interface we are using. We are not using more than one interface to route the packets which is received from the source to destination, right? So the next one is multicasting. So here if you see in the multicasting, there is a difference, right? So in multicasting, you have a group of destinations where you can share the source to different destinations present in this topology, right? So if you see in this topology, here the source is S1 and the destinations present is group of destinations. So here all the destinations are represented as Z1, right? Yes or no? So here if you see, for first router, it is using an interface of this G1 and it is using another router to travel the packet from source to destination G1, right? So here if you see, it is using not only one interface, one source is only one thing, it is using many routers to travel the packet to all the destinations present in this topology, right? So this is nothing but multicasting, right? So here what the router will do, it will forward the received packet by using several interfaces, right? So you know what are the interfaces present for a router R1 is, this is source, one is G1 and other interface is another router and other interface is another router. So this four links will be known as interfaces here, right? Yes sir. So here we will be seeing what is the difference between multicasting and multiple unicasting here. So if you check here, you can see the difference in the figure, right? So multicasting is nothing but we are communicating from one source to group of destinations present in this topology, right? So if you consider multiple unicasting, what you are going to do? So here what multicasting will do is it will start with one single packet, so that is source. So if you take the source S1, it is taking a single packet, and what it will do, it will make a duplications and it will send that data to the routers. So the destination address in each packet will have same duplications. So it will be having only single copy of the packets that will travel through any two routers which is present in the topology. So what is multiple unicasting here? We are using different packets here. If you see in this diagram, you can see we are using different packets from the source, which is starting from the source, and we have 5 different destinations here, right? So for example, if you wanted to send 5 packets, so with different unicast destination address, so it has a different destination addresses like D1, D2, D3, D4 and D5, right? So if, for an example, if you take a person wants to send an email message to a group of people, so we will be using multiple unicasting. So how do we do this? So the email software which we have, we will create the replicas of the message, and each with a different destination address. By sending, it will send one by one, right? So like this email will work, right? So this is a multiple unicasting example, right? This is the difference between multicasting and multiple unicasting. So here, if we wanted to use both multicasting and multiple unicasting, it is not really possible, because here multiple unicasting is not efficient, so it will create delays when it is reaching large group of people, right? So by using unicast routing, each router will have some particular domain, right? So in a table. So what it will define? It will define a shortest path tree. So how many possible destinations they can reach by using shortest path tree, right? So if you see in this example, they are using shortest path tree in unicast routing, right? So while using shortest path tree for unicasting, what you are going to do? So here we are using a router and which will receive the multicast packets. So here when it receives a unicast packet, so it has different destinations from more than one network, right? So when we are forwarding a single packet to members present in a present in a group, so what it requires a shortest path tree. So for suppose if you see here in this graph, we have different networks, right? N1, N2, N3, N4, N5 and N6. So if you consider the destination and the next hop address, so if you think N1 is the destination here, so how, what is the next hop for N1? There is nothing, right? Here there is nothing. So one way it is nothing, other way you can, if you take, there is a route called R1, right? Yes or no? So if you are handling for R1 table, how you will define? You will be taking all the possible ways, N1, N2, N3, N4, N5 and N6. So here, if you have any direct contact, then only you will enter that particular router in the next hop address, right? So if there is no direct contact, we will not enter any entries in routing table, right? So by using this tables, we will be finding what is the shortest path, right? So how do we find shortest path in unicast routing? We will be traversing each and every router, right? So we will be checking what, how much distance or how much network address it is taking to traverse from one router to other router. So by using routing tables, it will define what is the shortest path tree present in unicast routing, right? So here we are using shortest path tree for multicast routing, right? So we have each group here. We have two different approaches in multicasting, right? Yes or no? So in that, one approach is source based tree. So if you see here, you can see a source based tree which is constructed using the destination and the next hop routing tables by using the shortest path trees, right? Yes or no? So how do we use shortest path tree or source based tree? So this is one approach which is source based tree in multicasting, right? So if you see in this diagram, we have one shortest path tree for each group. So for each group, we can derive a shortest path tree, and for we have different groups here, right? So we have five different groups which is denoted as G1, G2, G3, G4 and G5. So if we want to, if a group is having a member called G1, so it should be loyal to all other four networks which is present in the topology, right? So you can see in the diagram, you have a representation of networks as G5, right? G1 to G5. And you have different routers. So here you are using multicast routing table for R1, right? So we can derive one shortest path tree for each group. That means we can derive five different shortest paths. In that, you can derive which is the minimum shortest path tree we are deriving. Using that, we will help the source to reach the destination, right? So this is known as source based tree approach. Here what we will do, each router will have at least one shortest path tree for each group. So that is known as source based tree approach here. So the next one is group shared tree approach. So here, if you see group shared tree approach, you have group which is sharing, you have each router having shortest path trees and it is designed with routers, right? So if you see in this diagram, you can see the multicast traffic is being distributed over all the networks, right? Through routers. So we have a router which will receive a multicast packet, and then it will encapsulate this particular packet into unicast packet, so that it can send to the core router which is present here. You can see a core router here, right? So it will remove the multicast packets and it will encapsulate and consults the routing table. So what it will do, it will take that multicast packet and it will consider the routing table, and then it will route the packet according to the routing table, right? So in group shared tree approach, what we are going to do, we are going to use only this particular core router, so that it will travel the data from source to destination. So we have only the core router which has a shortest path tree for each group. So this is used in group shared tree approach. So we have a taxonomy for multicast protocols. So if you see here, we have seen what is source based tree and what is group based tree, right? So if you see all this, these are the different protocols which are present under source based tree and group shared trees. So if you take multicast link state routing, it uses the source based tree approach. So we have seen what is link state routing protocol, right? Yes or no? So what is link state routing protocol? It is mostly based on the information of link, right? Yes or no? So it is using shortest path. Yes or no? So what is flooding broadcast here? So whenever we are releasing all the packets at a time to travel in a media, transmission media, it will occur flooding, right? So when we travel, open from source all the packets to reach the destination, so it will be creating a loop in the system if it is very congested, if the traffic is very high, so it will do flooding, right? So here RPF will eliminate the loop in the flooding process. So what is RPF here? That RPF is nothing but reverse path forwarding here, right? So we have different routing protocols. In that routing protocols, RPF is nothing but it is reversing, right? So if you take here source to destination, so the packet will forward through routers and it will reach the destination, right? Yes or no? So if you see the source here, it is forwarding a packet to router R1, and then it forwards that particular packets to R2 and it goes to R3, so on, right? Till it reach the destination, it will be going through a network, right? So now if you take here, one packet is being transmitted from R1 to R4 and R2 to R5 and R3 to R6, right? So it, it is like reversing the path, right? So when it is forwarding in one direction, it is again forwarding into another direction, so that what R5, R6 and R4 will do, it can again retransmit and it can go in backward direction, right? So this is known as reverse path forwarding. So while using this reverse path forwarding, we will be getting problems, right? So if you take in this example, we have three different networks, right? And we are using four routers here, and if we are sending through R1, it will go in this direction, right? So if we are sending through network 2, it will come in this direction. So there will be a conflict in one of the networks, and the copies of the packets will be stored, so it cannot recognize from where it has reached, because the two copies of the packet will be same, right? Yes or no? So RPF versus RPB. RPB is nothing but reverse path bridge, right? So if you see in this diagram, you can see what is RPF. RPF is nothing but reverse path forwarding. So here what we are going to do, we are going to prevent loops. Only one copy is being forwarded. So other copies will be dropped in RPF. So if a router wants to forward only the copy that has traveled the shortest path from source to the router, it will find that particular copy and it will use the unicast routing table, and the router will receive a packet and it will extract the source address by using this routing table, right? So this is how it is using in RPF. So how do we use differentiate between RPF and RPB is like, we have a reader here, right? So it will designate the parent, how it is determined. So if you see here, you have a designated parent router here, which will help the shortest path to the source. So the routers will periodically send this updating packets to each other by using RIP protocol, so that the routing information will be updated each time whenever it travel. So what it will do, it can easily will determine which router is the neighbor of that particular shortest path from the source, from where it got, right? So if we are having more than one router, so the router will have smallest IP address which will be selected, right? So RPB is will what it will do, it will create a shortest path by using broadcast tree. So what is broadcast here? What, in which direction the packets will travel from source to destination? That is nothing but broadcast, right? So if the source will send the packets to each destination, so in broadcast way it will guarantee that each destination will receive only one and only copy of the packet. So for that we are using this RPB. So if you see here, RPF, RPB and RPM here, right? So you have four different diagrams here, right? So if you see RPB here, it does not have any multicast packets that should reach only to those networks or which are active members. So here it is not efficient, right? By using the broadcast, using multicast packets. So to increase efficiency, what we have to do, we have to reach only to those networks which are actively participating in the group, in a particular group, the active members, right? For this we are using reverse path multicasting. So to convert broadcasting to multicasting, we are using the protocols called RPM, right? Reverse path multicasting. So if you see the designated part parent router of each network, so that will be responsible for holding the membership information. So here you will be using IGMP protocols, and if we start a message by using a router that is connected to different networks, so we need to find out where the packet multicast packet is reaching by using the router. So it will be sending a duplicate or a different messages to upstream the router, so that it will exclude the corresponding interface. So if you take different messages like prune message, graft message, so by using all these messages we can just upstream and downstream the data which is transmitted through routers, right? So we have, so here what RPM is doing and RPB is doing. So RPM is adding pruning, that is not the original message, and it is grafting to RPB, right? So that it will create a broadcast into multicast shortest path tree that will support the dynamic membership changes. So if you see here the group shared tree with the different routers, so you have a members and you have different routers present in this topology, right? So if you consider this diagram, you can see that we have different members and routers here, and we have different protocols present in group shared tree. Yes or no? One is DVMRP. So what is DVMRP? It is nothing but distance vector multicast routing protocol. It is similarly like distance vector routing protocol, but it is used in multicast. Because of that it will be using same RIP, and it will be used as a source based approach here. So we are using the distance vector multicast protocol here. So and we will be using CBT protocol, that is nothing but core based tree protocol. So it is used under group shared protocol. So you can see there is only one core router that will be responsible of all the transmissions which is going in that particular network, right? So it will be in the center, right? So if you see in this example or diagram, you can see the big one which is rendiverse router, right? So that acts as a core router in this design, right? So how do we form a tree? By using this point, R point, rendiverse router. So first we need to select what are the routers present and what is the unicast address of that selected router. So then we need to send a unicast message to show what it joins in that particular group, right? So if we are sending a message, that should pass through all the routers that are located between a sender and a router here. So here if you take a rendivirus router that acts as core router here, right? So whenever we are sending each intermediate router, so what it will do, it will extract the necessary information. That means it will remove the unnecessary information from the message, and the unicast address of the sender and the interface through which we are sending the packets will arrive, and it will forward that message to the next router present in this path. So whenever we are using this rendezvous router, what it will do, it will receive all the messages from every member of the group, and then the tree is formed through this particular router. So now every router will know its upstream router. That means the router which leads to the root, and it will know the downstream router as well. That means how it is ending its destination, or how it been transmitted. So here we will be knowing all this upstream and downstream routers by using this group shared tree with rendezvous router, right? So how do we send multicast packets here? By using the information of the tree, by using the source, and how to send a multicast packet to all the members of the group. We will be sharing all the details. So it simply sends the packet to the router, which is the core router here. And we are using unicast address with this rendezvous router, so it will distribute the packet to all the members of the group present, right? So this is how it shares in group shared tree. So if you see how we are sending a multicast packet by using this particular rendezvous router, we have two different ways, right? So one is unicast and other is multicast. So when we are sharing the group in a group, what it will do, it will go in different directions, right? So it is multicast, it is like one to many. So if you take the source, it can travel from R to D to this member, and it can travel this way, and it can travel in the backward direction also, right? So it is like it is having the unicast address in the routing table, and it have upstream and downstream information while it is sharing the data through rendezvous router, right? So if you see here, we are using this core based tree, right? So what it will do, the source will send the multicast packets. So this packets will be taken through core router. So the core router will again decapsulate the packet, and it will be forwarded to the all the interested interfaces which are linked in this topology, right? So PIDM. So what is this PIMDM here? So this is one other kind of protocol which is used like PIM is nothing but protocol independent multicast. So the name itself, it says it is independent, right? So if we consider two independent multicast routing protocols, one is protocol independent multicast. PIM is nothing but protocol independent multicast. So DM is nothing but dense mode here. So if we are using PIM DM or PIM SM here, so both protocols will have unicast protocol which is dependent, but similarly ends when we are using PIM DM. That is nothing but when there is a possibility to reach each router involved in multicasting, we will be using that in dense mode. So if you see PIMDM, it is used only in dense multicast environment. For example, it is LAN, right? Sorry. So PIMDM, so it uses RPF and pruning and all the strategies to handle the multicasting, right? So multicasting is nothing but one to many, right? So if we are using this independent protocol for unicast protocols, we will be using PIMDM protocol. So SM is nothing but spare multicast environment. So this is mostly used for WANs. So DM is used for LANs and SM is used for WANs, right? So it is also similar to core core tree, right? Core router tree, but it uses a simple procedure, right? So if you see here a logical tunneling which is present, so we have, so why we use tunneling here in multicasting? For example, if we take mbone, that is nothing but multimedia and real time communication. So nowadays it is increased more, right? Multimedia. So if we wanted to use or if we need any multicasting in the internet, we have small fraction of internet routers. So what it will do, it will multicast the routers. So the multicast routers may find another multicast router in the neighborhood to forward that particular multicast packets. So this might be a problem, and it can be also like give solution. It will take some time, but adding more and more multicast routers, there is no other solution for this problem, right? So for this particular problem, the solution is tunneling. So here we are using multicast routers, which are seen like a group of routers here, right? Yes or no? So on the top of it, we are using unicast routers here. And we are using the multicast routers that are not connected directly, but they are connected like logically, if you see in this diagram. So only the routers which is enclosed in the shaped circles, if you see here, so that are capable of multicasting here. So without tunneling, these routers are like isolated normal routers. So to enable multicasting, we make multicast backbone out of these isolated routers. So by using the concept of tunneling, so because of that, we call it as logical tunneling. So what is logical tunneling? It is established by encapsulating the multicast packets inside a unicast packet. So a multicast packet is encapsulated inside unicast packet. So whenever we are using multicast packet here, it becomes the payload or the data of the unicast here, right? So we are using both multicast and unicast packets here, because the multicasting, we are using multicast packets that is inside the unicast packet here. So whenever the intermediate, that is routers present in this diagram, wants to forward the packet, so what it will do, it will see the unicast routers and it will deliver to the packet from one place to, like one end to other end, right? So by using this, routers cannot exist until multicast routers become their neighbors. So for this we use a different protocols, that is M-bone tunneling and DVMRP. DVMRP is nothing but distance vector multicasting routing protocol, right? So M-bone is nothing but, what is M-bone? Multicast backbone, right? So why we go to tunneling? We have a problem with a small range of internet where we multicast with other range of internet to again to multicast packets we will be using continuously same process. So until we receive the neighborhood, we will be traveling, forwarding the packets to the routers, right, which is having internet. So it won't be giving a particular solution. So for solving this problem, we are going for tunneling, right? Yes or no? So if you see here the in M-bone you have different routers which is R1, R2, R3, R4. So here if you see in the frame you can see the source address, what are the multicast group address, and what is the unicast source address and unicast destination address present in this diagram, right? So what you will do in this M-bone, which is having different circles to all the routers, it is nothing but multicast routing, right? So the data packets will be encapsulated inside the unicast packets. So what is that data which is encapsulated, which is multicast packets, right? So this is about multicast routing protocols. So everyone understood? So what is your third module? No one remembers. Hmm? So this is your fifth module, right? So next module is sixth module. So what is your sixth module? I have given an assignment that you have to do use cases for chat application, right? Everyone completed doing it? Yes or no? So tomorrow we will be starting the sixth module. So in sixth module, tomorrow I will be saying process to process communication, right? So in sixth module, you will be getting the chat application here, right? So in sixth module, you have process to process communication, TCP, UDP, how you establish connections you already know, right? So how do you communicate by using TCP, UDP, and you have different protocols, right? DNS, FTP, Telnet, all this, right? And you have congestion control and quality of service. So tomorrow we will be discussing this congestion control. So what is the general meaning of congestion? So for example, if we are traveling in a traffic, it is like very congested way, right? So when we are waiting in a traffic, so no one can move from that place which they are stuck in the traffic on the road, right? So it is nothing but there is a load which is already stopped by giving signals, right? So when we are in traffic, we cannot move here and there because of the congestion, because of the way the vehicles are stopped, right? So that is the general meaning of congestion. Mm. So respond to your attendance. CO 1001. CO 1001.
1001 present, ma'am.
1003.
Present, ma'am.
5.
Present, ma'am.
7.
Present, ma'am.
2001,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
10, Miduna. 2012,
Present, ma'am.
13,
Present, ma'am.
Kaushik,
Present, ma'am.
Kavya Varshini,
Present, ma'am.
Alan John Patrick,
Present, ma'am.
Vishok,
Present, ma'am.
Mohammad Mushraf,
Present, ma'am.
Thomas,
Present, ma'am.
Muthu, Abu Raja,
Present, ma'am.
Johan Sai Rishik,
Present, ma'am.
Sibbol,
Present, ma'am.
Joel,
Present, ma'am.
Vishwantan,
Present, ma'am.
Samuel Joseph,
Present, ma'am.
Parkavin,
Present, ma'am.
Santosh Devan,
Present, ma'am.
5038, Nisha, 5039,
Ma'am, present ma'am.
Lakshmi Pranesh,
Present, ma'am.
Kishore,
Present, ma'am.
Arul,
Present, ma'am.
Preetika,
Present, ma'am.
Indra Kumar,
Present, ma'am.
Nitin Kumar,
Present, ma'am.
Samuel Jocelyn,
Present, ma'am.
Sujit Kumar,
Present, ma'am.
Daniel John,
Present, ma'am.
Mohammad Nawaz,
Present, ma'am.
Jebin Praisen,
Present, ma'am.
Srinidhi,
Present ma'am.
Praisy,
Present, ma'am.
Mithun,
Present, ma'am.
Lakshmi Narayan Reddy,
Present, ma'am.
Abhika Blessy,
Present ma'am.
Nitin Krishna,
Yes, ma'am.
Gifran,
Present, ma'am.
Hariharan,
Yes, ma'am.
Tripurna,
Yes, ma'am.
Sweetie Janish,
Yes ma'am.
Anurag,
Yes, ma'am.
Sai Ishwar,
Yes, ma'am.
Kumaraswamy,
Yes, ma'am.
Danush,
Yes, ma'am.
Dinakaran,
Present, ma'am.
Jashwant,
Present, ma'am.
Vinny Jacob, CS7077, 7081, Sudarshan Reddy,
Present, ma'am.
Shivani,
Present, ma'am.
Giflin Olivia,
Present, ma'am.
Junior Sam,
Present, ma'am.
Narsimha.
Present, ma'am.
So the absentees are CO2010, CS7077.
Ma'am, 2010 present, ma'am.
So what you are doing when I am taking attendance? Two zero one zero.
Ma'am,
I was waiting till you respond, right? What?
network issue, ma'am.
Now it got connected.
Yes, ma'am.
So the absentees are CS7077. So you all can leave. Thank you.